Hey guys, it's Corey again, and today we are going to talk about something that I saw in a recording. Someone was creating an Air AI agent, and they were in the advanced mode, and they started speaking in terms of if and only if. So, from the industry that I come from, that's got a very specific meaning, if and only if, and I think we're doing the same thing here since this has got computer science in it. We are building and designing or designing and building agents, and we're implementing combinational logic on the back end for that with to create business rules and to flowchart those things. So if and only if has a very specific meaning, and I've got that up here right now. I just pulled up an article on it, but this is exactly how I've learned it. uh, the if and only if is a biconditional statement, meaning that either both statements are true or both statements are false. So it's essentially an if statement that works both ways. So I had a professor tell me that many years ago, and it never really made sense. I grasped what they were trying to get at more or less, but this if statement that works both ways. This is Susie is selected if and only if Bob is selected. It means that Susie and Bob are either both selected or they're not selected. The symbols are this bidirectional arrow, thin, or the double arrow, or this little hamburger looking thing, or IFF. IFF apparently was first coined in the 50s. An author, I forget his name now, used that IFF to identify what if and only if was in a logical statement. So it's really a compound conditional statement leading into a sequence of events. So let's take a look over here uh, at the truth table for it. If you take a look at this, there's P and Q. Normally we put A and B, but for some reason they've got P and Q. So it says P if and only if Q. So if P is true, Q is true, then the output is true. If either one of them are false, the output is false. And if they're both true or both false, then it's true again. So this is right away when you look at this, you say, oh, well, this is very much like an XOR gate. And that I will go through the XOR gate here really quick. We've got A and B, and we have A is false, B is false, we get a false. If either one of them is true, then we get a true out. And if we get both true, except for if we get both true, we get a zero out. That is exactly the opposite output table of this guy. This one is both true or both false, you get a true out. Everything else is a false. This is both true or both false, you get a zero out. So the XNOR gate is actually the implementation of the if and only if. So it has a very specific case to it. It's much like this is much like an AND gate, except for it has one additional case where they're both false that you get a true out. So we want to be careful when we're designing and building our logic and to actually get the output that we're after. We want to be sure that we use the correct terminology, the correct thinking about the process, and the correct thinking about the combinational logic that we implement to build something. This particular one would cause a much different output in certain cases than just an AND gate would, or it would cause, if you were trying to implement this instead, the statement of if and only if is pretty specific, and we need to be pretty careful with that so that we get the right outputs in the right cases.